In 1977, a monumental event occurred that would forever change the way humanity viewed the cosmos. NASA launched a space probe named Voyager 1, and no one could have anticipated that more than 45 years later, this tiny spacecraft would still be transmitting data across the vast emptiness of space. What started as a mission to study the outer planets of our solar system has evolved into one of the most impressive and lasting achievements in space exploration. The Voyager mission is not just a testament to human ingenuity, but also a symbol of humanity's desire to reach beyond the confines of Earth and explore the unknown. When Voyager 1 was launched, its primary mission was to explore the gas giants, Jupiter and Saturn, and their moons. In 1977, the technology we had at our disposal was far from what we would consider state-of-the-art by today's standards. The idea that a small spacecraft, built with technology from the late 20th century, could make the journey across the solar system and into interstellar space was nearly inconceivable. NASA's engineers and scientists worked tirelessly on the probe's design, ensuring that it could survive the harsh conditions of space and transmit data back to Earth. Voyager 1's twin, Voyager 2, was launched shortly after, and together, the two probes formed a vital part of NASA's ambitious plan to explore the outer reaches of our solar system. What was remarkable about Voyager 1's mission is that it was designed to take advantage of a unique alignment of the outer planets, a rare event that only occurs once every 176 years. This alignment allowed Voyager 1 to take a direct route through the asteroid belt and use gravitational assists from the planets to increase its velocity, enabling it to reach the outer planets in record time. The plan was audacious, but it worked. Voyager 1 reached Jupiter in March 1979, only 18 months after its launch. The images it sent back from Jupiter were nothing short of spectacular. The probe captured stunning pictures of Jupiter's turbulent atmosphere, its powerful storms, and the iconic Great Red Spot. These images transformed our understanding of the largest planet in our solar system, revealing the complexities of its atmosphere and weather systems. But Voyager 1's achievements did not stop at Jupiter. After its successful flyby of the gas giant, the spacecraft continued its journey towards Saturn, where it arrived in 1980. During its flyby of Saturn, Voyager 1 provided humanity with its first up-close images of the planet's famous rings. These images revealed intricate structures within the rings that had never been observed before. Voyager 1 also made important observations of Saturn's atmosphere and its magnetic field, expanding our knowledge of this distant world. Special attention was paid to Titan, Saturn's largest moon, which had long intrigued scientists due to its dense, hazy atmosphere. Voyager 1's observations of Titan would later spark speculation about the possibility of life or prebiotic chemistry existing in the moon's thick atmosphere. As Voyager 1 continued its mission, it sent back a series of groundbreaking discoveries, including the first direct observations of geological processes on another celestial body. Perhaps the most surprising discovery came when the probe revealed active volcanic activity on Io, one of Jupiter's moons. This was a monumental finding, as it marked the first time scientists had observed volcanic eruptions on another world. The eruptions were shooting plumes of sulfur and volcanic gases into space, demonstrating that Io was far more geologically active than anyone had previously imagined. This discovery changed the way we thought about moons in our solar system, highlighting that these celestial bodies could have dynamic, active processes much like Earth. Voyager 1's achievements were not limited to the outer planets. In 1990, the spacecraft was instructed by NASA to turn its camera back towards Earth and take one last photograph of our planet from its vantage point in space. The resulting image, known as the pale blue dot, became one of the most iconic images ever taken by a spacecraft. From a distance of about 6 billion kilometers, nearly 4 billion miles, Earth appears as a tiny, fragile blue speck in the vastness of space. The image serves as a powerful reminder of the insignificance of our planet in the grand scheme of the universe, yet it also highlights the beauty and uniqueness of our home. The pale blue dot image was taken at the suggestion of the renowned astronomer Carl Sagan, who spent much of his career reminding humanity of the preciousness of life on Earth. In his words, the image was a reminder that the Earth is a very small stage in a vast cosmic arena. However, Voyager 1's mission was far from over. In August 2012, the spacecraft became the first man-made object to cross the threshold into interstellar space, leaving the protective bubble of our solar system. This momentous achievement marked a new chapter in the history of space exploration, as Voyager 1 became humanity's first messenger into the unknown realms of the galaxy. At this point, the probe was so far from Earth that it took more than 16 hours for its signals to reach our planet. This distance would only continue to increase as the spacecraft continued its journey through the interstellar medium, the vast, mostly empty space between the stars. For over a decade, Voyager 1 continued to send back valuable scientific data, including measurements of the solar wind, cosmic rays, and the interstellar medium. These measurements were crucial in helping scientists understand the environment beyond the influence of the Sun. Voyager 1's instruments detected a mysterious plasma stream in the interstellar medium, a discovery that puzzled scientists. The plasma appeared to be denser than expected, suggesting that there was more going on in the void of space than previously thought. Some scientists speculated that the plasma might be a measurement error, while others suggested that it could be evidence of unknown phenomena in the interstellar medium. In 2021, Voyager 1 experienced a temporary setback when its telemetry data appeared to show that the spacecraft had lost its orientation and was tumbling uncontrollably in space. Scientists initially feared that the probe had malfunctioned and that its mission might be coming to an end. However, the problem was eventually resolved when it was discovered that the data had shifted due to a glitch in the spacecraft's system. The issue was corrected, and Voyager 1 resumed its mission, continuing its journey through space. But this was just the beginning of a new set of challenges for the aging spacecraft. In the fall of 2023, something unexpected happened. Voyager 1 sent back a stream of confusing data that made no sense. The spacecraft had transmitted a jumbled mix of ones and zeros, which appeared to be an imprint of its internal storage system. This was not a typical transmission from the spacecraft, and scientists were initially at a loss to explain it. Further analysis revealed that the probe's internal systems were still functional, but the transmission of data had been disrupted. The cause of the disruption remained unclear, and NASA's engineers were left scrambling to figure out how to fix the issue. At this point, it was becoming increasingly apparent that Voyager 1's mission was nearing its end. The probe had already surpassed expectations by far, continuing to send valuable data long after it was supposed to have stopped transmitting. The reality was that Voyager 1, like all machines, had a limited lifespan. Its power source, the radioisotope thermoelectric generator, RTG, was slowly running out of fuel, and its instruments were beginning to show signs of wear and tear. Despite the best efforts of NASA's engineers and scientists, the likelihood of finding a solution to the communication problem was growing slimmer by the day. If the communication problem cannot be resolved, Voyager 1 will continue its journey through the vast expanse of interstellar space, silently carrying the story of humanity's achievements to the stars. Even though we may no longer be able to track its progress, the probe will continue to travel, drifting farther and farther away from Earth. It will eventually reach a distant star, perhaps in thousands or even millions of years, and who knows what future civilizations might find it. Voyager 1 carries with it a golden record, a message to any potential extraterrestrial life that may encounter the spacecraft. The golden record contains sounds and images from Earth, including recordings of bird songs, the laughter of children, and the bustling noise of our cities. It is a time capsule from humanity, a snapshot of life on Earth at the time of its launch. As we look at Voyager 1 and reflect on its incredible journey, we are reminded of the remarkable achievements of the men and women who made it possible. The probe has become a symbol of human curiosity, ambition, and resilience. It is a testament to the spirit of exploration that drives us to seek answers to the big questions about our place in the universe. Voyager may first be nearing the end of its mission, but its legacy will continue to inspire generations of scientists, engineers, and dreamers for years to come. The message it carries, both literal and metaphorical, will live on, a reminder of humanity's desire to reach out and touch the stars. In the end, Voyager 1 has achieved far more than anyone could have predicted. Its journey through space has expanded our understanding of the solar system, the interstellar medium, and the universe itself. It has provided us with images and data that have reshaped our view of the cosmos and our place in it. As we look to the future, we can only imagine what other discoveries await, whether they come from the farthest reaches of space or from the depths of our own curiosity. Voyager 1's story is not just the story of a spacecraft, it is the story of humanity's quest for knowledge, a quest that will continue long after Voyager 1 has passed beyond the stars.